welcome for this lesson. Today we are going to talk about chemical formula. Now, as we talked about in our previous video, we saw that in this periodic table, we have got what we call atoms. For instance, we have atoms that are in group number 1, 2, 3, up to group number 8. Now, in nature, these atoms are not commonly found as free or individual atoms. Rather, they are found combined with other atoms. For instance, we have metals, these atoms in group 1 combining with atoms in group number 6 or group number 7 or even group number 5 to form compounds. For instance, we have compounds like common salt, which is sodium chloride. We have a compound like rust, which is iron 3 oxide, and so on and so forth. Now, this portion here represents this periodic table here shows just the first 20 elements, but we have some other elements that are usually called transitional metals, like calcium, like zinc, like copper, and so on and so forth. So they are not shown here, but as we move on our this course, we shall be using them in certain areas. Now, we saw that if you can refer back to our video on structure and bonding, we saw covalent and ionic bonding, and we saw that compounds like water are usually formed as a result of hydrogen and oxygen forming covalent bond. Now, today we are going to look at something quite different, and this we are going to see bonding in ionic chemical formula for ionic compounds. Now, ionic compounds are usually formed between metals. Now, group number 1 is metals, number 2 and number 3 is metals. We have aluminium here. Then we have group number 5, we have nitrogen. We have number 6 here is we have oxygen here and sulfur. We also have halogens, which are in group number 7. So when these metals combine with non-metals here, we usually form what we call ionic compounds. And now we want to see how we write the formula of these ionic compounds. Now, to start with, we are going to start with sodium fluoride. Sodium fluoride, this is a formula for a compound that is formed between sodium and fluorine. So, sodium usually is in group number 1. That means it loses 1 electron to form a positive ion like this. So we have a positive ion like that. Fluorine is in group number 7. So this means that it usually gains 1 electron to have a stable electronic configuration. So it have a charge of -1. So these are called oxidation number of +1. It's not a must that we write 1. In most cases, if you have a plus, we know it is 1, and we have 1 minus, we know it is -1 like that. Now, when these two compounds now combine, they will combine and form sodium fluoride. Now, what usually happens, now this fluorine here, this -1, which is an oxidation number, we usually call it now, the combination number for this, or valency, is 1. So, chlorine has got a valence of 1. That is the combination power for that, for chlorine. Now, for sodium, it is also a 1. So the formula of this compound is, now we are going to swap this to 1, and this one now is going to be swapped there. So we have 1. So the formula of this element now become 1 sodium and 1 fluorine. In this case, we don't put now the 1s because it is obvious, common sense, that this is 1 and this one is 1 also. So the formula now becomes like that, is sodium fluoride. Now, if you look at this charge here, a molecule, an ionic molecule, usually have a charge of a net charge or total charge of 0. You see, we have a positive and a negative 1, so the charges neutralizes. Now let us look at our next molecule, which is sodium oxide. This one is formed between sodium, which is in group 1, so it loses 1 electron in the outermost energy level to have a stable electronic configuration, so it's going to have a positive 1. Then we have oxygen. Now oxygen is in group number 6. So it gains 2 electrons to have a stable electronic configuration like that. So now, the valency or the combination power for oxygen is 1, as you have seen in our previous video, in our previous compound. Oxygen now has got a combination power or valency of 2. Now this one is coming from this charge here, the charge of -2. So the formula of this compound is, now we are going to swap. This one will come here, and these two will come here. So our molecule looks something like that. But we said that we are not going to, when we have 1, we don't indicate this value here, because naturally this one is just a 1 like that. So the formula now becomes, our formula is, for sodium oxide, is this one here. Now, as we have seen, why do we need two sodium atoms or ions for this case? Now, as you see, we have a positive 1 and then we have a -2 here. So this charge here, for our molecule to be neutral, we need to add an extra sodium, like this, an extra sodium. So this basically is this here. You have two charges, 2 positive charges, because we have 1 and 2 to neutralize. It equals to this negative charge here. So our molecule now, we have a neutral charge like that. So let us look at the next molecule, which is aluminium. Aluminium 3 chloride, like that. Now aluminium is in group number 3, as you can see here. So aluminium loses 3 electrons in the outermost energy level for it to have a stable electronic configuration like that. Then we have chlorine now. So the chlorine is in group number 7. So it gains 1 electron to have a stable electronic configuration, so a negative charge of -1 like that. So when these two molecules combine, we have our aluminium there, and we have our chlorine here. Now from this oxidation number, aluminium has a combination power of 3. A combination power of 3, like this. This one is coming from this oxidation number. And chlorine has got 1, like that. So what usually happens, we are going to swap this. For this formula, we are going to, these 3 will come here and 1 will come here. This means that you have 1 aluminium and 3 chlorines like that. 1, we don't put 1. Whenever you have a 1, we eliminate 1. We are left with these aluminium atoms. Basically, it's a 1. And then we have 3 of this. So this is the formula for aluminium 3 chloride. Now, to make sense of this, why is this necessary? It means that 3 chlorine, 1, you have these 3. We have 1 of this and 3 of this. Why? These are 3 plus. So we need a 3 negative for these charges to balance. So you have 1, 2, 3. So this chlorine each contributing 1 negative. So the total, we have a 3 negative. So plus, now it is going to neutralize. Because we have a 3 positive, we need a 3 negative. And that's why our formula becomes 1 aluminium and 3 chlorines like that. Now, if we move forward to the next molecule, we are going to have magnesium oxide. Now, magnesium is in group 2. So, it loses 2 electrons. It's a metal. It loses the 2 electrons in the outermost energy level to have an oxidation number of +2. Oxygen is in group number 6. It's a non-metal. It acquires 2 electrons to have an oxidation number of -2. So, at the end of the day, what usually happens, we have our magnesium there and an oxygen there. Then we have the valences or the combination power for magnesium is a 2, like that, and for oxygen also is a 2, like that. So when you swap these two, we're going to have a 2 there and a 2 there. So this becomes our formula. Now, because these two are equal, we have 2 here and 2 here. When you divide 2 by 2, you get 1, 1. So the ratio in which these are combining is equal. So the formula now, the 2 cancels out. And the formula for magnesium is this one, magnesium 2 oxide. As you can see, we have 2 here, 2 negative and 2 positive, so they cancel out. And our molecule is there having a net charge of 0. Now, our last molecule would be aluminium 3 oxide. So we get aluminium in group number 3. So it has a charge of +3 like this. Then we have oxygen having a charge of 2 there. Now, it means that now this aluminium here will have an oxidation, a valency of 3 or a combination power of 3. Oxygen, we have a combination power of 2, like this. So when you swap this, the 2 comes here and 3 will come here. So the formula now will be something like this. Now the reason for this means we have 2 aluminiums. You can make sense of this like that. And then we have 3 oxygens. Now if you look at this, 2 plus 2 plus 2, we have 6 negatives. And this 3 plus and 3 plus here, we have 6 positives. So at the end of the day, these charges, the positive charges and negative charges, are cancelling out. So our molecule have a net charge of 0. Now, in the next video, we are going to look at the reaction of these metals or ionic compounds, the formula of chemical formula for ionic compounds that have what we call polyatomic ions or radicals. Now, remember, these ions that we have used today, positive or negative, are called monoatomic ions because it is just one atom. But next time you look at carbonates, sulfates, and phosphates, those ions are called radicals or polyatomic ions. Remember to subscribe, and we meet in the next video.